control. So we talk about if state. When you talk about control flow or control structures, there are two main types of control flow. We have your if statement and you have loops. If statement, it's used to check if a condition is true. So it's more like if a condition is true, do something, else do something. So it's more like, okay, if, so you start that condition with if. So if, in this case, we say if mineral equals, so we have our mineral equals to, what was our mineral initially? So in this case, mineral is calcite. Let's replace that. Okay, let's go. Our mineral is calcite. So it checks, it's not, remember when I said if you're using your double equals to, it checks, is that true? So it prints that it's false. So you say if mineral is equals to quartz, print you're correct. If I run this, nothing is going to return because mineral is not equals to quartz. Yeah? So in this case, if I now say, okay, I write another if statement. If mineral is equals to calcite, print you're correct. Else, print mineral is print the name of the mineral. So in this case, mineral is calcite, so it just goes through the first one and says you're correct. But if our mineral, let's make, if mineral equals to quartz, if mineral is equals to quartz, what does it do? It goes through the first statement. If it's not true, it goes through to the next one. So let's see. We print this because mineral is equals to quartz, it prints you're correct. But in this case, I'm asking is mineral equals to calcite. If it's correct, we say you're correct. Else, we say mineral is this. So let's print this. Okay, if we print this and run this, it goes through the first block. Mineral is not calcite. Normally, if I didn't have this else, nothing will be returned. But I've gone to give it else. That means if this is not correct, then do this regardless. Do this anyways. So it's okay. This is not correct. So the mineral is quartz. So telling you the mineral is quartz. So let's try again. So you could also have multiple conditions rather than say, okay, mineral is not calcite. Instead, rather than going down to else, you could also have L if. So say, okay, if mineral is equals to calcite, print you're correct. L if mineral is equals to gypsum, print mineral is equals to gypsum, right? So let's say now my mineral is gypsum. If I say if mineral is equals to calcite, print you're correct. So let's print. So it goes through the first one. Is this true? No, it goes through the second one. So if this is then true, it stops it there. So when that condition is met, it automatically stops. Okay, so let's run through. So it goes through, say you're correct, then if you put mineral is gypsum. So if, for example, if mineral is equals to calcite in this case, so let's just have it as different. Okay. So if mineral is calcite in this stage, it just runs the first one and ends it there. Or if you say, let's say mineral is equals to diamond. So it goes through the first one, mineral calcite, no. Mineral gypsum, no. Then just goes to the final one, mineral, the name of the mineral. So that's what if statement does. Okay. So with if statements, okay, you could also have multiple conditions. So not multiple conditions in regards of if and elif, but in this case I'm putting an if statement. So if quartz hardness, so it uses greater than on integers or floats. So if quartz hardness is greater than gypsum hardness, we'll say quartz is harder than gypsum. If not, that means gypsum is harder than quartz. Okay, let's see. So if we run this, it says quartz, what's quartz hardness? This is quartz hardness. Then let's see what's gypsum hardness. I think that's 2. So gypsum hardness is 2. So it shows that if quartz is greater than gypsum, the hardness, that means quartz is harder than gypsum. Okay. Then we go on to for loops. For loops are used to iterate over items or over variables or over different data items. So you start a for loop with, so similar way where we have if statements. So the keyword, it starts with if, then so you always have a keyword. Something I didn't mention is with elif you can have multiple elifs. So notice we have one if, you have one else, but you could have multiple elifs. as well. You could have multiple ellipses. Then if you want to go into complex, you can have more subset of if. For example, if you have this if statement, you could also have another if statement under that if statement, but that's going to be complex. You don't have to think about that now, but just have that in mind. You could have multiple. So when you start writing multiple conditions, you can think about that. Yeah, also before we go into the loops, you could also have give multiple conditions. So for example, let's see. So let's see, let me print something. Let's say mineral if mineral equals to quartz, I can now say and let's say hardness. Let's put hardness. Let me create hardness. Okay, so let me create a new variable called mineral. Let me say mineral equals to quartz. Let me just create a new variable called hardness equals to impute. So just impute hardness of mineral. So impute hardness of mineral. Okay, so I can say and hardness is greater than 7. Let's see. Let me put. I'm just thinking about. Do we have? What's the hardness of calcite? Anybody with an idea? What's the hardness of calcite? If you have an idea, let me know. Okay, let's say use this. Okay. Calcite and hardness. Let's put hardness is less than 7.
Should be 3, I guess. I think hardness of is 3.
Yes, okay. So print or let's say hardness of. Okay, let's use this instead. Okay, so we have quartz hardness. And let's say print. So what do we want to print? So we want to say if the name of the mineral is calcite and the hardness is less than 7, like less than the hardness of quartz, we can say print calcite is less quartz. Let's put something like that. Quartz hardness of calcite. Let's say hardness of calcite is less than quartz. So what does this do? So it will ask you, because this is a block of code. So I say impute hardness. I can say impute hardness of mineral. So if I run this, let's put this and say what's the hardness. So before that, let me put 3, for example. Nothing is done. Let me make my mineral equals to calcite. So let's do this. So I just show you how to impute multiple conditions inside an if statement. So for example, mineral is calcite, and I say, okay, impute your hardness of mineral. So I say mineral, let's put 3. So what would this do? Okay, because impute takes in a string, so I need to convert this to an integer upon reception. So if I do this and run this again, so it puts that I put in 3. So it shows that mineral is equals to calcite, and also the hardness is 3. That means hardness is less than. So let me just print this. Hardness. So what hardness I've put into, for example, let me run this again. So if I run 3, it shows that my hardness is 3 and my calcite, name of the mineral is calcite, and is less than 3. That means calcite is less than quartz. So the hardness of. So that's how you can impute. So when you're using and, the 2 conditions must be true. But if I'm using, I can choose to use or. Let me use or statement. With or statement, you just need one to be true. So if you're using or, you don't, it's just one. So for example, if I run this and put hardness, if I put in 8, it's still going to print out the result because I use or. So with or, you just want one condition to be true, but with and, the both conditions must be met before it executes that code. Okay, is that clear enough? I feel like I'm losing people at this stage. Is it getting more complex? Is it getting more complex? Yeah, I know. I can understand if it is. The most thing is just it's like an overload of information, but it's just about trying to break it down mentally. And by the time you go over it again, that's why I shared my notebook. If you go over it again, it now begins to kind of marinate it, for lack of better words. You begin to digest it better. So you just take your time, absorb as much as you can, but spend time to go over it again. The truth is that you have to be consistent with these things. You have to go over it, go through it, for it to stick better. Okay, so we'll talk about for loop. For loop are used to iterate over an iterable. So there are items that could be iterable. There are some items that are not iterable. But let's look at the iterable item. For example, a list is iterable. So you can say, okay, let's say our mineral is, we have this as our mineral, right? Because, okay, for item in mineral, print minerals. So all it does is, okay, it's going through every item in minerals. So I say for item in mineral, so how many items do we have in mineral? 4. So it goes through all the items in a mineral. So similar to the if statement, you start with a keyword, and the keyword for a for statement is 4. So when you start writing, so when I talk about at the beginning, when I talked about declaring a variable, it's not right to declare a variable using any of the keywords. For example, I say I want to declare a variable and I'm using if equals to something. That means, like, that's why it's even highlighted, shows that don't use any keyword to declare a variable, similar to for. So try to avoid this keyword when you start declaring a variable. And so a trick I tell people is when you type something and if you see it highlighted, it shows that it means something in Python. So try to avoid it. Or see you want to use type equals to something. Type, you know that type is used to check a type of a variable. Then if you're using it, it's going to like disrupt what the computer knows as type. So avoid those keywords. Okay, so for example, then if I say, okay, for item in minerals, print items, print item. So I can choose to say print. Let me use a keyword. Item is mineral. Let's put this. So it depends on how you want it to be. So I can put a comma since I'm using this. So I can say print item is mineral. So what this is doing is it prints out all the item. I can say I can choose to print CV. I can say, let me see, print length of item, length of item is, remember, how do I check for the length of item in a variable? Anybody wants to attempt that?
Use the length keyword.
Okay,
LEN.
yes, using the length keyword, it returns the length of that item. So let's see. So it prints length of item. So it goes through all of them. So it goes through the first one. It's quads. It prints the length of quads. It goes through the second one. Print. So also in a for loop, you can have multiple for loops, right? So for example, I say, okay, for minerals in minerals. So it's going to pick quartz. But now I want to check item in quartz. So I can say for, let's say for I in minerals. So it's more like looking, so the first time it goes through minerals, it picks out quartz. So for items inside quartz, so it's more like going into a different print. What do I want to print? Let me print out the first letter. Let me print out I0. So it goes print. Let me put something. Let me do something else. First item in. Let me use a first item in I is. So let me use a formatted string. So what it does is, so we'll break this down. Let's go through. Or let me see, first item in this, not this, rather I should do print. That's not what I want to say, just print I. Okay, let's do this. So if I go through, what it does is, for the first loop, it goes through what item in mineral. The first item in mineral is quartz. What's the length of the item? I have 6. So what it now goes again, another for loop for items in minerals. That's for every item in quartz in the first instance. Print out all the I's. So the same thing. So this is when you have multiple for loops. So you could also have another for loop under the for loop. So just depending on hierarchy. So you notice that they all have hierarchy. So the first for loop, you see that it's indented. Indentation is key. It shows hierarchy. Then the second for loop shows that everything I have under this, everything that will be indented following this, it is going to be under this other for loop. So that's how you have to understand indentation. Okay. So where we have for loop, we could also have while statement. So you could also have an if statement under a for loop. So everything is just dependent on what you're trying to achieve. So so in this case I have multiple for loops. Let's see if if I have this, so rather than having another for loop, let me see if I can have another for. If mineral equals to, let's see, if mineral is equals to calcite, what do I want to do in this case? Let me break. So you can use the break statement to either end a for loop or an if statement. So what I'm going through is go through all the items. When you get to calcite, stop the loop. So let's run this now. So in this case, it goes through quartz, it goes to gypsum, it goes to calcite. Notice that fluorite didn't print out because I told the statement to break it when it gets to calcite. So that's why you can now start doing things like that. So everything we're going to do you're going to build on it later. It's just about forming the fundamental basic knowledge that you can always build on. When you look at programming is just about looking about conditions, writing statements, writing functions that meet certain criteria. You do that later. Then you can also look at while loop. While loop is similar to for loop, but with while loop you look at if while something is true. So as long as this is true, keep doing this thing. Okay. So I can say in this case I have my rock hardness equals to 10. So I say while rock hardness is greater than 3, print current hardness of rock is rock hardness. But see what I did here. So there's this incremental iterator. What this does is, while this is true, so it goes through the first time, it reduces. So the first time we have our hardness as 10. Using this plus minus 1 shows that subtract 1 from 10. And you continue doing this, but because of it's a while statement, so while rock hardness is greater than 3. So when it gets to the point that rock hardness is no longer greater than 3, it stops that. So let's run this. So you notice that it goes through the first one, it prints 9. So on another thing again, it depends on how the position of your thing. So I want to print it out before I subtract. So the first time I go through, it prints my rock hardness is 10. That's fine. I go through again, it prints it 9, it goes through again and it continues printing that. But when it gets to 3, say when it's, as long as it's greater than 3, so when it's equals to 3, it will stop printing. So your incremental iterator could be plus as well, or you could say, okay, let's do -2. Let's do a -2. Let me just control Z. See, let's still have that. I could have this as -2, so I'm subtracting 2 from the item. So it goes through, the first was 10, it subtracts 2, it makes it 8, subtract makes it, so it just does that until this condition no longer holds true. So you understand how to use the incremental iterator, so you can always, so in some other cases you could have it as while this is equals to this, so you can executing something, but while that condition is continues being true, keep doing this. I can also add an if statement, so you can say if, and I say if rock hardness equals to, let's make it 7, so that's the hardness of the rock. Can say rock print rock is let's see, rock is quartz if, okay, so let me make this, let's make this 0. So I want to use multiple conditions to see. Okay, let's start with, so I want to say if, let's say if rock hardness is 10, so let me see if I can pull up the hardness scale to see. Okay, if rock is 10, let's say that means rock is, let me use rock hardness or mineral hardness. Mineral is diamond has the hardness of 10. If it's 7, it would not be L if, or then it goes through, let me put another L if again. So but this should be under L if this is equals to 3, let this be calcite. So what this does is goes through, if when you get the hardness as 10, it prints that the mineral is this. Let me put this. Okay, so let's run this through and see what it does. So it continues running through. When it gets to quartz, the same mineral is quartz because the hardness is 7. Oh, let me do this. Let me print. So your hierarchy is very important. What comes in first before that? So I want to do the subtraction first. So when you print mineral hardness, it's 7. It says mineral is quartz. When it I can choose to say when it gets to calcite, break it and break it so that it doesn't print out anything outside calcite. So when it gets to, so use your break statement to end a loop, a for loop or a while loop, or even an if statement. So it goes through. So we have while loop, we have our if statement, we also have multiple elif that tells it to do something when it gets to a particular position or a particular point. Okay. Are we following? Yeah, I can understand if you're confused at this point. It's normal. You just have to you just have to take time to come back to it, and you get to stick better. Okay, so now let's go on to functions and models. When you start looking at Python, functions and models are very also important. These are useful things you will use as you go through, as you start coding, you start using it. So whenever you write your code, it's good to be not to repeat yourself. Try to make your code efficient. So in trying to make it efficient is trying to reduce the number of codes you get to use, or number of codes you get to write. So in this case, so whenever you, so I say function is a reusable block of code that performs a specific task. So a function should perform a particular task. You should not have a function that does a lot of things. So it should be specific what that function does. So it helps you organize your code, makes it more readable, and helps you avoid repetition. So when you want to write your function, you start with a keyword def. So it's more like defining the function. Define def, the name of the function, and the parameter you want inside the function. In some cases, you don't have to have a parameter, and you should also have return. So let's start with a function. Let's say a function that greets. Let's say greets. I can say enter your name. I can say, okay, put name equals to inputs. What is your name? So always know when to use the input. What is your name? So you have your def on that line, and when you're done with that, you use your column. Then what do you want to do? I want to print welcome. Let's say print. Let me use a string welcome. Then I put name. So it shows that, okay, input your name, or I could put something. Let me not make this confusing enough. Let's put this Control X. So the function asks you whenever you run that. Okay, let me put V. So what this function does is it takes in an input called name, and what the function does, the function name is greet. So it prints and say welcome, you call your name. So for example, now let's say our name is, I'll ask you your name, then say if I want to call that function, I could just say greet name. So the name of the function is greet, and because the function always asks for your name, you say name. So now what is the name of what name do I want to call? Let me say Kelechi. My name is Kelechi for today. Kelechi. So what that return is, okay, I didn't run this function, no. So let me call that again. So welcome Kelechi. If you run it again, if you put a different name and put which persons, let me call Ife this time, and runs it to tell you welcome Ife. So your function does something. So what does this function do? The function greets. So welcomes whatever name you call in. So we could have another function that say add. So whatever you put in two values, and it returns the addition of the two values you put in. So the name of that function is add. So whenever I call in, so for example, I want to call in the function, execute that function. I just call, let's put 5 and 7, because the function declares that you must always give it A and B. So in this case, it gives it two values and returns the addition of the two values. It could also have, let's say, have it as 100 and 85. What does it do? To add the item, it's 185. In this case, add it. So in some cases, you might say, okay, I don't want to always specify the number of items. You could put something like an argument, more like an argument that specifies. So, okay, that specifies, then it sums all the item in the thing. So whenever I call this add, even if I have just two items inside, I can say, okay, add. I could choose to put, let me see, I could put 2 and 3 or 2 and 4. It adds them. It returns the sum of them by using the sum keyword. Then I could say add. In this case, I have multiple items. So you have to understand, what do I want my function to do? Then you can now specify how you want your function, what you want your function to calculate. Okay. So in this other case, we have a function that calculates density. So what it does, it calculates the mass. Density is mass over volume, right? Is that density? I hope I'm correct. Yeah, density is mass over volume. So you said calculate density. So it does mass over volume. So that's what that function does. So whenever I call the function, the first, so you should always know that there's positional argument. So for example, when I declare my variable, the first item I give it is my mass. The second item I give it is volume. So that's the same thing. For example, if you have your, let me split this. So for example, if you have your mass as 10 and volume as 50, if you give it this way, the function will say that your mass is your 50. So you have to be specific on how you position the item. Or if you want, for example, in this case, because for example, if we say our mass is 50, volume is 10, when you run this, it's okay. But in some cases, for example, you want to move it anyway, you cannot specify that my volume is equals to 50, while my mass is equals to 10. So in this way, it calculates it the other way. So you have to specify, okay, what I want. So you have to follow the position. If you're not following the position, you have to specify which is which and what is what. So you see, it depends on what you call, your result might be different. So you have to know how to position your arguments. Okay. Okay. So then the next thing, so this is how you, so there are different ways you can write function. This is the way you can write function. You can write function for anything you want to do. So for example, I have this function. So whenever I need to calculate density, I don't always have to do the calculation. All I need to just call calculate. Let's see, if I just say, all I need to do is calculate, let's say just call this, calculate this. If I want to put, let's say volume is equals to 50 in this case, and this is equals to 1000, mass equals to 1100. So this would always what, so you, rather than having to always do density over this, if you just call this function, it returns. So these are ways to and in some cases, in this case we just have 2 lines of code. In some cases you could have function that does something like a long step, so you could have like 10 blocks of code, but you just summarize them inside the function so that you don't always have to write the 10 blocks of code. Okay, then we also have modules. There are different modules in Python that you can use for different things. Like a popular one is maths. So there are different, so some of those math functions, for example, you use some parameters. You could do maths.py that gives you like the pi value. So for example, if I let me run this and let's do maths.py. When you run this, it returns 3.1. So this is value of pi. So these are some, you can do some math.sum, math.square roots. I can do, let's do math.square roots. So you could do cosine, different calculation. Let's use square roots now. So these are square roots. So if I want to, what's the square root of, let's say 49? So you return 7. So these are some standard math functions you can use. So using the math module, you can use that. So there are other modules. You can also go online and search what are the modules you can use. Python modules. So there are lots of them. So depending on what you want to do. So in this case, we want to calculate the volume of a spherical mineral. So using this formula, so pi, so rather than declaring pi equals 22/7, you could just use the math.py to call that, and you have your radius. So in this case, I want to put it in a function. So rather than having this, always writing this, I could just write a function that returns the def keyword starts the function, the name of the function, the arguments you want inside the function, use a column, then what do you want the function to do, then what do you want the function to return. So your function should always return something, ideally should return something. In this case, I want to return the volume of the spherical mineral. So in this case, whenever I put let's say if my radius is 10, this will be the volume of that mineral. Or in some other cases, if I have my volume as let's say 0.6, it calculates the volume for me, and that's the volume of that spherical object. Is this clear enough? Is this clear enough? Okay. So I'm going to send so I have a short exercise for you to do. So I'll give you time to do that. So I'll share the link to the exercise so you can download the notebook. If you have access to Colab, you can also use it on Colab, Google Colab, to get the notebook. So the question, let me see if I can open up that. So this is the exercise. So I have 6 exercises for you to do. I think it just summarizes everything we've done today. So sorry, I'll just send that to you shortly. Okay. Okay, so you can go online, follow the link in the chat to download that notebook. And we have the first exercise is create a program that asks the user for the hardness. So you put in the hardness of the mineral and you then identify what mineral is it. Giving this hardness scale, you can specify what mineral is it based on that. So you want to write your code as well. So a tip is to use a for loop or use an if statement or a combination of both. So okay, if mineral is X, so I don't want to go through that, then you can specify. Then second exercise is to get what is the, so you have a dictionary, this dictionary called the Mohs hardness scale. So you say if how do I get the hardness of diamond from this? Then the next question is to write a function that calculates the pressure at a depth. So this is the formula you use. Let's see, this is the formula you use. Sorry, let me move this. Okay. So using this formula, calculate the pressure of it given depth below seawater. So the formula is I just create a function that does that. The exercise number 4 is to write a program that asks the user to enter a temperature, and you specify if the temperature is high, low, or medium. So for if it's less than 25 is medium, is low. If it's between 25 and 55 is medium, and if it's greater than 55 is high. Then this 5th exercise is to write a program that converts, so you get a temperature from 0 to 20 in degree Celsius, then convert every item in that list to Kelvin. I hope this is not too difficult. Yeah. And I think for now we can do away with question number 6. Let's just skip from 1 to 5. Okay. So I think in this class I'll just attempt the first one. Then I would like to get your feedback, and I can always post the solution also in my GitHub for you to get. But I'll just attempt the first question. Let's see how we can solve it together. But the other questions, I wouldn't do that. I wouldn't solve that. I want to see what you can do with the other questions. Then we can always come back. So we have, okay, let's start writing. So there are different ways to approach it. The question is, create a program that asks the user for the hardness of minerals and identify based on those. So I can say, okay, a program, hardness of mineral hardness equals to, I can impute enter mineral hardness to check. Just put mineral hardness. So I want to start printing. So let's see. So we have our hardness from 0 to 10. I can say for let's say, because the range is from 0 to, let's say from 1 to 10. Let's say for range, okay, instead of using shells, okay, let me just use only if statement. So if mineral hardness, let's say if mineral hardness is, let's just, if it's greater than 10, I can say print. So if the mineral is the hardness is greater than 10, I can say mineral is harder than diamond, because diamond is the hardest diamond. So let's see. Then I can also put an elif statement, so it will be multiple blocks of elif. Elif mineral hardness is equals to 10. You can print mineral is print mineral is diamond. Then I can, let's just duplicate this. Okay, see, so if I have this, I'm just so we'll get to edit it. So and if the mineral hardness is equals to 9, I can say the mineral hardness is random, and I can say if it's 8, so it's about following the same logic. So if it's 8, it's topaz. If it's 7, it's quartz. Okay. Let's run this and impute a mineral. So you say enter the mineral hardness. So let's put 5, for example. Okay, so it's always the impute returns a string, but we want an integer. Okay, let's go that again. So if print the mineral is apatite. If I put, let's put 2, 3. So this is just like a simple solution to the answer. So for example, if I put, let's put a question, let's say if I put hardness as 20, for example, so mineral is harder than diamond. So that's why I put this. And if anything is greater than 10 is harder than diamond. So I can also put this in a function. So let me create a function using that. So define a function check hard. So the function can be, let me make the function check mineral get mineral name or something, get mineral. So with that, all I need to do is mineral. So if I want to define the function, I need to impute the mineral hardness. Then I can just copy this and put it in here. So in this case, indentation is key, so I just have to indent everything. So the shortcut to indent a block of code. So why is that now? Why is this still returning an error? Print. Okay, sorry, this is the error. Okay. So whenever I print get mineral, I'm putting a mineral hardness. So for example, I get the get mineral. I say, okay, which mineral has an index of 6? It will return autoclaves. If I do the same thing and say, okay, let me put a random number. Let me put, let me see, 8. Which mineral has an hardness of 8.0? Let's see what this will return. Mineral is topaz anyways. It's, yeah, topaz. Is that clear? You see how you start using functions and things like that?